It's kind of like 12 minus 2, which is 10x. And then the minus 8 just comes along for the ride. And that's the answer. So forward, outside, inside, last. What if I have 2a plus 4 times 3a minus 5? How do you multiply these together? Again, the first terms, 2a times 3a. 2 times 3 is 6. A times a is a squared. The outside terms are supposed to go FOIL outside. 2a times 5. This one and this one. 2 times 5, 2 times negative 5 rather, is negative 10. And the a comes along for the ride. The inside term is 4 times 3a, which is 12a. And the last term is 4 times negative 5, which is negative 20. Right? And to simplify that, 6a squared comes along for the ride. Negative 10a plus 12a is kind of like 12 minus 10, because 12 is the bigger number. So that's going to give me plus 2a, and the minus 20 just comes along for the ride. Okay? So it's really not too bad. You just need to focus on doing forward, inside, outside, last. And if you forget the little acronym, you forget the little shortcut method, you could always do it the way that I showed you the very first, which is just treat the outside thing as if it were x and go forward. Okay? Now what if I had 2t plus 3s times 3t minus s? Okay? The first terms, 2t times 3t. 6, 2 times 3 is 6. T times t is t squared. Outside, 2t times negative s is negative, because negative times positive gives me negative, 2ts. Okay? Inside is 3s times 3t. 3 times 3 is 9. And then s times t is simply st. And then the last term is 3s times negative s, which is negative 3s squared. Then I can simplify that, right? Because 2ts is the same as 2st, right? Because I can move the order of these around no problem, because it's just simply multiplied together. So this is really a like term with this. So that leaves me with 6t squared. 9 minus 2 is 7 st minus 3s squared. Okay? And you can flip the order around here because this is multiplication, so these are in fact like terms. Okay? What if we had something that looks like x plus y times x plus z? Forward term is x times x is x squared. Outside is x times z, which is simply xz. Inside is x times y, which is simply xy. And the final term is simply yz. yz over here. And there's really no way I can simplify that any further. Okay? Alright, we're making some progress here. Let's go ahead and do one more that's sort of similar. 4t minus u times negative 3t plus u. Okay. Well, what's the first term going to be multiplied together? 4t times negative 3t. Let me go ahead and continue down here. 4t times negative 3t is negative 12t squared. Right? The outside term is 4t times u, which is 4tu. The inside is negative u times negative 3t, which is positive, because negative times negative gives me a positive, 3tu. And the last term is negative u times positive u. Negative times positive gives me a negative. U times u gives me a u squared. Okay? And I can go ahead and simplify this. This is going to equal negative 12t squared. 4 tu's and 3 tu's gives me 7 tu's. And then the minus u squared just comes along for the ride. Okay? So it's not too bad. Forward, outside, inside, last. Or forward, inside, outside, last. However you want to do it. As long as you do the multiplication of those terms and you add the results up, you'll get the right answer. Okay. Let's see here. Now this is something that's just a little bit different. It's kind of a neat problem I just wanted to point out. What if I have something like r plus 4, r minus 4? This is the same as all the other ones. It's a FOIL type problem, but has a little bit of symmetry because I've got an r plus 4 and an r minus 4. So they're very similar. Let me show you what happens when you have a problem that's written like this. The first term, r times r, is going to give you r squared. The outside term is r times negative 4, which is negative 4r, right? The inside term is 4 times r, which is positive 4r. And the last term is 4 times negative 4, which is negative 16. Now look what happens here. I've got a negative 4r and a positive 4r, which is sort of like they cancel out because 4 times 4 minus 4 is 0. So the answer is going to be r squared minus 16. And I just wanted to point that out because this is actually going to be useful later on. When you have something like r plus 4, r minus 4, you're going to get an answer that's going to have less terms because some of them are going to cancel out. Don't memorize that though. That's just kind of a neat thing. Okay. The next problem I have is sort of a more advanced problem, and I want to do it because this kind of thing might be like a bonus problem on a test or a quiz or something like that. But it's very, very simple. It just takes some time. What if I gave you something like 4t plus 3 times t squared plus 2t plus 3. Now look at that. How the heck you're going to do that? You can't really use the FOIL method because it's not of the form something plus something times something plus something. You've got an extra plus in here. So at first glance it's like, geez, how am I going to do that? And the answer is very carefully. But what I want to show you is this is mathematically what we're doing, and this is sort of equivalent to how I explained how FOIL works in the first place. What I have here, what I'm really doing with FOIL is I'm taking, let me just kind of backtrack just a little bit and go down here. If it were 4t plus 3 times, and if the answer was t squared plus 2t over here, if this were what I was trying to multiply together, then it would be FOIL, forward, inside, outside, last. But I want to explain more about what's going on here, and then it'll help us figure out how to do this problem up here. When I'm doing this, all I'm doing is I'm taking the 3 out of the equation temporarily, and I'm distributing the 4t in to both terms. That's going to be 4t times t squared plus 4t times 2t. That's kind of like one distributive property, okay? And then I write that down. And then I add to that, I cover up the 4t, and then I distribute the 3 in to both cases. You can see I'm going to get 4 terms. The first couple terms are going to be 4t times this and 4t times this, and the last couple terms are going to be 3 times this and 3 times this. You're going to get 4 terms. That's why FOIL has 4 terms in it, because all you're really doing, it's a mathematical trick to help you remember it, but all you're doing is you're distributing the first term into each thing, and then you're also distributing the second term into each thing. And because it's used so often in algebra, they actually give it a name called FOIL. Okay? Now, knowing this, Could you take a guess at how you would tackle this problem? Because FOIL isn't going to help you. What we can do is we can cover up the 3, and I can distribute the 4t into each of these terms. I'm going to get three terms there. And then I can cover up the 4t, and I can distribute the 3 in, and I'll get 3 additional terms. So I'll get a total of 6 terms. So let's go ahead and do that. And then in the end, we'll add them all up, and we'll simplify, and that'll be the answer. So forget about 3 for a minute. I'm going to put my thumb over 3. 4t times t squared is 4t cubed. This t times t squared is t cubed. Plus 4t times 2t is 8t squared. Plus 4t times 3 is 12t. Those are the first 3 terms. Easy enough. Now I'm going to cover up the 4t. 3 times t squared is 3t squared. 3 times 2t is 6t. And 3 times 3 is 9. So these are the 6 terms I told you we were going to get here. Okay? Now let's simplify. Is there anything else with a t cubed in it? No. So 4t cubed comes right down. Is there anything else with a t squared in it? Remember from the other lecture, like terms. In order to be like terms, it has to have the same variables and the same exponents. This is a like term with this. I can add them together. 8 plus 3 is 11, plus 11t squared. Is there anything else with a t in it? Yes. 12t and 6t. 12 plus 6 is 18t. And finally, the 9 just comes along for the ride. Okay? And that's the answer. This is the answer to this multiplication. So notice with FOIL, when you have 2 things multiplied by parentheses with 2 things, you're going to get 4 terms in the end, and you can simplify them down. And whenever you have something like this, you're going to get a total of 6 terms, and you can simplify them down. Again, don't attempt to memorize any of that. It's just simply something kind of cool. And I wanted to point that out because sometimes they don't even talk about it in the book, and you're sort of expected to figure that out on your own. It is not difficult. You just need to know what's going on here. Okay, so let me go ahead and erase this, and then we're going to go ahead and solve some equations. We haven't solved any equations in a long while, but now that we have some additional skills and tools like FOIL and like terms and other stuff, we can solve some fairly cool equations. So let's go ahead and do that. What if I gave you an equation like s minus 4 times s plus 1 equals s squared plus 5. Now, remember, this looks complicated, and you might be thinking, oh, I'm going to freak out here. Okay? The goal of an equation is to get s by itself on one side of the equal sign, and we've been doing that. And also, I've been telling you from day one, if you don't know how to solve a problem, simply do what you know how to do and you know is algebraically legal and see where it leads you. It's like putting a puzzle together. You can't visualize all the pieces together at once. You've got to kind of put one piece of the puzzle in at a time. And so I've just taught you this piece of the puzzle. I know how to expand that, so let's do that. We're going to use FOIL. First terms, s times s is s squared. Outside terms, s times 1 is simply s. Okay? Inside terms, negative 4 times s is negative 4s. And the last terms, negative 4 times 1 is negative 4. And I'm simply going to carry over the s squared plus 5 over here because I haven't even touched that. Okay? First thing I notice is I have an s and an s here, and they're like terms, so I can combine those. So s squared, s minus 4s is negative 3s, because it's kind of like negative 4 plus 1, and that's going to give me negative 3. Negative 4 gets carried over, and the right-hand side of the equation, I haven't touched it, so I'm just going to write it down again. All I've done is add these two terms together in the middle. Okay?